Let us see this Euler's equation, e raised to pi I plus 1 equal to 0. This is the most beautiful equation in math, and it was created by a mathematician, Leonhard Euler. In this equation, we have the symbol pi. We know that pi is a transcendental number, and pi can also be taken as that irrational number 22 divided by 7, or you may know find the value for pi as 3.14159, etc., using any computer applications. We also know the value for I as square root of -1, and it is a complex number. And what is this I? Suppose if I have an equation x squared plus 2 equal to 0. It is difficult for me to find the square root, the roots for this equation x, because x will be square root of -2, plus or minus square root of -2. And even your calculator will give an error message because you cannot find the square root of a negative number. You cannot find a real root for this. So we define square root of -1 as I, and hence your root for this equation will be plus or minus root 2i. And you have a complex number x plus iy, where x is the real part and y is the imaginary part. So we also have this symbol, the math number e, which is in fact limit n tending to infinity 1 plus 1 by n whole raised to n, which we have used quite often in calculus. And this e is also a transcendental number which lies between 2 and 3. This number also lies between 2 and 3. Now, the number e was described by Jacob Bernoulli. He says that if you are depositing $1 with an expectation of 100% interest rate over the year, even if you are increasing the number of times the interest is given to you, over the year you will be getting only 2.711, which is in fact the value for e. So you can talk about this equation. E is limit n tending to infinity 1 plus 1 by n whole raised to n. Now Euler, who lived during this year 1702 to 1783, expresses this equation as e raised to I theta as cosine theta plus I sine theta, which is a complex number. In fact, Euler was a son of Bernoulli's friend, and that's the reason why Bernoulli encouraged Euler to explore more on mathematics. If we take a unit circle, and any point on the unit circle can be taken as a complex number x comma y. So suppose if I'm taking this point as xy, this is the x distance and that is my y distance. If this angle is theta or phi, then x divided by, that is your adjacent side, x divided by the hypotenuse is equal to cosine theta, or you know x is equal to cosine theta, that is your x coordinate. And y, opposite side divided by hypotenuse, is your sine theta, and your y is sine phi. So your x coordinate for a complex number on the unit circle will be cosine theta or cosine phi, and y coordinate of any point on the unit circle will be sine phi, which is given by Euler's formula e raised to ix equal to cosine x plus sine x. He has included the number e after his name, Euler. Let us assume that we have a point here. The complex number is here. So it touches the point 1. When you rotate it along this unit circle, when it takes an angle of pi, it comes back to this -1, you see. So that is what he is trying to prove. We also have come across these complex expansions for cosine x and sine x, and also the expansion for e raised to ix or e raised to x will be 1 plus 1x by 1 factorial plus x squared by 2 factorial plus x cubed by 3 factorial, etc. Now, the series expansion for cosine and sine are known to us. So when you combine them, you can also get the value for e to the ix as cosine x plus I sine x. Now, coming to this Euler's identity. Let us take e raised to I pi plus 1. E raised to I pi is cosine pi plus I sine pi. We know that sine pi is 0 and cosine pi is negative 1, and hence negative 1 plus 1 is equal to 0. We all might have come across this t-shirt joke where they have these symbols, e raised to I pi equal to negative 1 on the t-shirt, and it says, pi says get real. It tells I get real, because you know that I is not a real number, it is a complex number. And I tells pi be rational, because pi is an irrational number. And that is the joke we always hear right from our school days. Now maybe we can add one more punch to this, a punchline to this. We can say, E tells both I and pi, join me. And we will be 1. There, the minus sign is there. E tells I and pi, join me. We will be 1. So e raised to I pi equal to negative. This is the Euler's equation, or Euler's identity. Paul, a professor of the University of New Hampshire, in his book, which was dedicated to Euler, says, this Euler's identity is the exquisite beauty of math. Mathematics writer Constance has expressed that Euler's identity is the most famous formula in all mathematics. And also, a poll of readers conducted by the Mathematical Intelligencer in 1990 named Euler's identity as the most beautiful theorem in mathematics. In another poll of readers that was conducted by physics in 2004, Euler's identity tied with Maxwell's equations as the greatest equation ever.